Am I on?
Yeah, you're on.
Oh,
This is the countdown. Am I on?
Supposed to come in. Good evening, everyone, and welcome to. Oh boy, it's going to be one of those nights. Good evening, everyone, and welcome to Live Sky Astronomy, proudly brought to you by the Gravity Discovery Centre and Observatory. Now, for those of you who don't know who I am, my name is Rick. I'm the Chief Astronomer here at the GDC Observatory, and joining me tonight in the Tech Goblin hovel is Mitch. There he is. There you go. He's kind of in the darkness. But we've got a beautiful, cold, clear night out here, so we've saved you the trouble of actually going outside and freezing your butt off, because it is cold out here in rural Gingin. And yeah, boy, oh boy, we've got a beautiful, clear night. We've got the moon up, and we've got a whole bunch of other targets we want to show you tonight. So what we might do is oh, here we go. We've got, Carlitos from Sydney. What are you doing in Sydney there? Anyway, I hope you're enjoying Sydney. Yeah, we still have to catch up and do that interview again. That'll be awesome. So yes. So what we're going to go to first, Mitch? We're going to go to the Eyes Galaxy in Markarian's Chain.
We'll have a quick look at Stellarium here.
Yep.
So this group of galaxies is sitting. Wrong one. Sitting just around the constellation of Virgo and the tail end of Leo.
Leo's butt.
Yeah, basically anywhere you look around Leo's butt is just full of galaxies.
Yeah, there is just loads.
Lots and lots. So the ones that we're focusing on at the moment are these two galaxies just here in the middle, collectively known as the Eyes. So if we go ahead and we jump over to a live view from our telescopes, we're using two telescopes this evening. We have...
Let's put some lights on them. Here we go.
Lights on.
There we go.
So we've got two telescopes running in tandem this evening. We've got an 8-inch Schmidt Newtonian and a little 4-inch Schmidt Cassegrain. So we've got ZWO cameras on the back of both of those. We're going to be having a look at some of the faint targets first, and then we'll be wrapping things up this evening with a nice bright one with the moon. So if we jump over to Copernicus, our 6-inch Schmidt Newtonian, this is an image we've got coming hot off the sensor for you guys here.
There we are. And there's the Eyes Galaxy right there, and just above it is Messier 86. So this forms a part of a large string of galaxies, a chain of galaxies called Markarian's Chain. Now, M86, what can I tell you about M86? Oh, crumbs. It's about 50 million light years away. So this is further than, say, ones like the Andromeda Galaxy and the Sombrero Galaxy, which we'll show you a little bit later on this evening. So this is way out there. And like Mitch said earlier, it's in the constellation of Virgo. So Virgo and Coma Berenices and all that sort of area there, Leo, is just rippling with galaxies. Now, what can else I'll tell you about? They were both discovered, of course, by Charles Messier, a French astronomer, back in 1781. So that was a while ago. Of course, galaxies remained a bit of an enigma for quite a while. No one knew what the heck they were back in those days. They saw them as these small spiral smudges, and they had no idea as to what they were. Of course, this led German philosopher Immanuel Kant to suggest that these were vast collections of stars very, very far away, and he called them island universes. And of course, this resonated with some of the astronomers of the day. They thought, wow, that's a pretty amazing insight. And the other half of the astronomical community thought, well, that's the biggest load of crap we've ever heard. And of course, that divided the astronomical community into two. One championed the island universe theory, and the other one scorned upon it. But it all came to a head in the early 1920s, where there were two camps of astronomers. One camp headed up by a fellow called Heber Curtis, who championed the island universe theory, thinking that these objects were much farther away from the confines of the Milky Way Galaxy. He also believed the Milky Way Galaxy was only 30,000 light years across, and our sun was in the middle. So that wasn't right. But then on the opposing side, of course, was a fellow called Harlow Shapley, who said, no, 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 these small little spiral nebulae are exactly as they appear to be, small and close by and found within the confines of the Milky Way Galaxy, because he suggested the Milky Way Galaxy was much bigger than what it actually was. I think he estimated to be around 300,000 light years across, and everything that we saw was actually a part of the Milky Way Galaxy. Boy, was he wrong. But nevertheless, they had what's akin to a academic cage fight, also known as a debate. And this, of course, was the Great Debate. If you Google the Great Debate, you come up with the Great Debate between Shapley and Curtis, 1922, held at the Smithsonian. And both sides argued and championed their ideas and scorned upon the other and thought you're a lump of blockheads and whatever. Anyway, but unfortunately, the actual argument was unresolved because they needed a way to measure the distance to these small spiral structures to answer the fundamental question, are they close or are they far away? They hadn't the foggiest how to do it, but little do they realize that a couple of years before, there was a remarkable astronomer by the name of Henrietta Swan Leavitt who actually discovered a relationship on certain types of stars called Cepheid variables. And variable stars, as the name suggests, they vary in brightness. So they go from bright to dim, bright to dim. And between the succession of brightenings, the longer they take to go from bright to bright, the brighter they are. But they do come back to the same luminosity. And she said, well, this is a perfect, what's called standard candle and a perfect measuring stick. And what she meant by that was these standard candles their intrinsic brightness can be measured, and depending on how faint they are away from you, you can calculate the distance or calculate the estimated distance to these faint stars. Anyway, using that technique, Edwin Hubble was imaging the Great Spiral of Andromeda. Today we know it as the Great Andromeda Galaxy. He took a series of photos over a couple of weeks from the Mount Wilson Observatory in Southern California, and he found these stars in the actual disk of the spiral nebula that flared up to be bright, and he thought, oh, they were exploding stars, they're nova stars. And then suspecting that they wouldn't come back, he took another photo a couple of weeks later and saw the exact same stars flare up to the exact same brightness. And this got him puzzled a little bit. And then he realized, oh, that must be the stars that Henrietta Swan Leavitt was talking about. And he applied the necessary calculations, a bit incorrectly, but he got the distance. And he said, I estimate the distance of these Cepheid variable stars in the Great Spiral of Andromeda Galaxy or Andromeda Cloud to be approximately 1 million light years away. It's actually 2.5. But it still answered the fundamental question, are these far away and outside the confines of the Milky Way Galaxy? And yes, they certainly are. So that is a very, very brief story on how the universe was discovered. And that happened on the 6th of October 1923 when Hubble took that famous plate, which now is at the Mount Wilson Observatory. Anyway, let's go and have a look at another galaxy. Should we head towards the Leo Trio? Leo Trio, yes.
Messier 65.
Messier 65, Messier 66, and the NGC number I cannot remember for the life of me.
No one ever remembers the NGC.
I know. I feel sorry about that.
Ever remembers.
We should start up and click on it, see what it says.
So we've got Messier 65. We've got NGC 362A, also known as the Vanishing Galaxy. I mean, aptly named because it seems to continuously vanish from our minds.
Yeah, that's it. Oh, its NGC number certainly does. Yeah, so I'm just going to check and see if we've got anyone else saying hello.
We've got Jenna Devine over on YouTube saying,
Jenna.
Hi, Rick. Hi, Jenna. How are you going? Great to have you with us this evening.
Yes. Now, last time we were talking to you guys who joined us on our last live Sky Astronomy session. Of course, we were broadcasting from sunny, warm, and absolutely stunningly beautiful Exmouth, because, of course, that was for the total solar eclipse, and boy, oh boy, what an event that was. My colleagues did an absolutely splendid job holding down the fort while I was running around being interviewed by various TV stations, and that was a real pain in the bum, but I certainly got my exercise in on the day. But nevertheless, it would have been much better if I actually spent time there with my colleagues, that would have been so much better. But as it turns out, we're already planning for the next eclipse to grace our shores in 2028. So the 22nd of July 2028 is going to be all the way up north near Lake Argyle. And it's a bit of a hoof to drive up there, but we're looking at other forms of transport to get ourselves and our equipment up there. That's going to be an interesting trip because, yeah, boy, oh boy. I mean, we drove up to Exmouth in one hit. We left at, what time we leave? About 1:15 in the morning, and we rocked up at about 4 o'clock or thereabouts.
Yeah, about that.
But we stopped and futzed around and caught up with some colleagues in Carnarvon. But nevertheless, it was an amazing road trip. We had a lot of fun. And if you haven't seen the footage of the eclipse, well, just look on our YouTube channel and it's there in all its 3-hour glory. Yeah, it was pretty darn amazing. And to experience it at live, being there yourself to actually see this thing was just incredible. So that little spiel, I know it sounded a bit long-winded, but that just gave Mitch enough time for to slew the telescope over to the Leo trio of galaxies. That, of course, is the classic time-honoured tradition of stalling for time.
So again, we're still sitting around the bum end of Leo. As I said before, guys, this area is absolutely chockers with galaxies. If I just turn on all deep sky objects.
Hang on, we got Ben Johnson saying, come to Sydney or Dubbo. If you're referring to the eclipse, nah, sorry, dude. The reason why, it's probably going to be pissing down with rain. And up north is going to be perfect 30 degrees, clear, cloudless skies. And although in Sydney you won't have the risk of being eaten by a crocodile if you go swimming in Lake Argyle. But I'm not going to go swimming in Lake Argyle, so I think I'm good. Anyway.
So the eastern states say we're always 2 hours behind. That also means we're 2 hours behind the weather.
Yes, that's right.
So, yeah, just as I was saying before, we've got here the constellation of Leo. We can see the moon. It's currently sitting right in the middle of Leo's face. These curved stars along the back here represent the mane of the lion, and this triangle structure is his tail. So where we've got this little blue square, that's where the telescope is currently pointing at. We're just waiting for the first couple of exposures to come off the sensor for that. But just off here is where we were looking earlier at Macarian's chain. So just in here, that's the eyes. It's a bit more of that structure. It's a long chain of galaxies, but as you can see through here, all of those little orange, red, and blue circles, those all represent galaxies sitting out in this region. It's absolute hotspot.
Just going to say a quick hello to Kevin from Calvary Astronomy. How you doing, Kevin? Long time no see. Hope you're doing well, mate. And Ben says July in Dubbo is clear and 20 degrees on good El Nino year. All right. Well, we'll think about it. Yeah, Dubbo's all right. They've got a really nice pie shop there. So yeah, we might have to stop there. Adam says, nah, check the weather for 22nd July 2028. Fine and sunny in Sydney all day. Is that the crystal ball weather prediction service? Is it? Well, or tarot card maybe. Yeah, I'll except for the eclipse. Yeah, okay, no worries. Thanks for that, Adam. No worries. Sorry, Mitch. Off you go.
All right. I'm just getting things set up. I've got a couple of comments coming in here from YouTube. Yep. Lady Deal Kirk says, howdy.
Neighbours. Howdy, neighbours.
Howdy, neighbours.
Oh. Where are you? You're a neighbour. You must be close by.
If you're in the observatory next door, I've got some questions to ask.
Shoot up a flare. Yes.
Daniel Dawson. Hi, gents. Really enjoyed the eclipse coverage, and it's good to see the live Sky Astronomy back. Thank you very much, Daniel.
Yep.
And Sparky Sims. G'day, guys. Enjoyed your stream for the solar eclipse so much, I thought I would stop by and see this one. Cheers for stopping by, mate.
Nice work. Thank you.
See familiar faces back.
Here we are. The Leo Trio. Wow, let's look at NGC, whatever your name is. Have a look at that. There's this beautiful dark dust lane. This it's probably the edge of the spiral galaxy. Hang on a sec.
Hang on a minute. Your ugly mug has very conveniently covered up.
Oh, okay. I'll pretend to be a galaxy. There we go.
Bear with me 1 second here, folks, just while I move Richard's head out of the way.
Hang on a sec.
Face camera. Okay.
Pull over.
No.
You're under arrest.
No.
Sorry.
Unlock that group there.
This wonderful beanie that I've got with the emergency police lights on the top was courtesy of my friend and colleague, Fabian, who lives in Paris at the moment, he's going to be, he and his family going to be moving back, and he got me this beanie. It's extremely warm, but great comedic value with this blue flashing light. So I tend to bust people on a tour night just for not asking inappropriate questions such as how much is this telescope worth? You can do better than that.
You want to stop messing with my exposures?
Sorry. But it's fun.
Oh, Lady Dealkirk says, Gabada, near Moore River. So you really are just next door.
Yeah.
Beautiful.
Hey, you should come along to the Gin Dark Sky Star Party when it's on next. So I'll tell you about that. So every year we have this event called the Gin Dark Sky Star Party, which we host at the Near Gabby campgrounds. And this year we did it in March, and the weather was absolutely smashing. So it was beautiful, warm days, cool nights, not too cold, and the skies were just perfect, absolutely dark as. And the reason why we do this is because, well, we want to show off this soon-to-be International Dark Sky Reserve, the very first one in Western Australia. And we want to share the night skies with everyone. And what a great opportunity to get people to come up to the Near Gabby campground. You can bring your own tent, swag, or whatever, hammock, and sleep under the stars. And if you've got your own telescope or astrophotography rig or even a pair of binoculars or just your own eyes, I highly recommend bringing them too. We'll bring a couple of our own telescopes along, and we just have the best time. It's really good. And then during the day, we have events here at the Gravity Discovery Centre. We have guest speakers, so some friends and colleague of ours, Dr. Bruce Jondra from Osgrav and University of WA, and his PhD student Hayden Crisp. They both do smashing talks, and of course we get the occasional special guest coming in to do talks about whatever. And we also have solar viewing and tours of the Zadko Observatory and this, that, and the other. It's just absolutely great. So we'll start putting information out closer to the time, probably March next year. But certainly put that in your calendars and keep a lookout on our Facebook page and come along and join the fun under the beautiful dark skies here at the Gravity Discovery. Oh no, in the Shire of Gingin, the Western Australia's first international dark sky reserve.
Speaking of Facebook, we've got a couple of questions coming in through here. Yep. Ben Johnson, which hamburger do you prefer, Centaurus A or Leo? I'm going to have to go Centaurus A.
Centaurus A, yes.
That was the first hamburger that I knew.
Yep, that is absolutely.
Tim comes in. Hi, Rick. How much is this telescope worth?
Oh, is this Tim K?
Yep, Tim K.
Hey, Tim, how are you? Well, let's see. This telescope here, so the white one, in fact, we didn't pay for any of them. So they were gifts. So the small one, the little blue Mead, that was, it came as a package from, they used to be the old education department telescopes, and of course they weren't used properly. Some of them were a bit abused, and we took them in and we cleaned them up and gave them a good meal and a hot shower and a bed and looked after them. And of course now this particular one, the small one, we call Buzz, as we actually name all of our telescopes. And of course the white one, the what's this, 6-inch? Yeah, it's a 6-inch, not 8.
6-inch.
And that one was given to us by a smashing fellow who lived down in Cottesloe. And we had an event way back when on the 31st of January 2018. Of course, some of you may remember that was the Super Blue Blood Moon, and we put on a free event. And boy, oh boy, that event was something else, because we did this event free, and we put it up on our Facebook page. And we thought we'd advertise it as far as putting on a who's going to attend, yes, no, maybe, whatever. And I thought, we're only going to get like about 500 people. Well, the page got something like over 10 million hits. There was about 92,000 people who said they were interested, and a little over 9,000 people said they were coming. Of course, this struck abject terror into my heart, and I was all set to actually go to the airport, jump on a plane, and never come back. But thankfully, I stuck it out, and with the help of a lot of people, and a lot of people from the astronomical community of Western Australia, or Perth and Western Australia, they came down with their telescopes and helped us out, and we had an absolutely smashing night. Anyway, this fellow who was an old science high school laboratory technician, saw what we did, and he called us up and said, I have a couple of old telescopes that I can no longer use. Would you like them? And of course, we graciously took them. And yes, now one of them is in use for our public events. In fact, a couple of them are in use, and we still have a large mirror that we're going to put together, a nice big 17.5-inch Newtonian telescope, which we're going to replicate what we've got on here, but much bigger, so we can collect some serious photons. Anyway, I digress. Ben says, yeah, Centaurus A has better buns. Yep.
Wholeheartedly agree there, Ben.
Yep. It's all about the buns.
Always about the buns.
I know no, I'm not going to say it.
No, we're live. Lady Leo Kirk from YouTube, we're down south then, but we'll try to get there next time. My son Alex, astro-obsessed kid, if you would remember, would love to be there. We watched the solar eclipse in Learmonth. We saw you guys.
Did you? Well, I apologise for that. We hadn't washed in a couple of days. No, actually did. We washed the day before. We went to the local swimming pool. No, the change rooms at the swimming pool. I have to clarify that.
I was going to say, that makes it sound worse than it
was.
I
know. But no, it was good. Good that you were there and you enjoyed the spectacle. It was pretty darned amazing. It was my first total solar eclipse. I've seen annular eclipses and partial solar eclipses and lunar eclipses, of course, but that total solar eclipse, I tell you what, boy oh boy, that was really something else.
I'm kind of torn at the moment. So
What's
next
that?
On our menu for this evening, we can either hit up.
We haven't spoken about this. I've just been banging on. So before we go, so tell me what you got next on, then I'll just have a quick talk about these three galaxies.
So we can either go to M104, Sombrero Galaxy, or I'm swaying to what Ben was talking about and potentially Centaurus A.
Yeah, let's go to Centaurus A.
So
before you go, or I should say, you can start slewing them now.
I'll stand up, yeah.
And I'll just wax lyrical about these three suckers here. So Messier 65. So I know that Messier 64 and Messier 65 are 42 million and 37 million light years away, respectively. NGC Obscure is 35 million light years away. That's all I know about them, but I'm just going to have a quick look. 65, that'll do. This is quite interesting. Again, this was discovered by Charles Messier in 1780, who described it as a very faint nebula without stars. And it's like, that's because there are a lot of stars. They're very small and very far away, Charlie. So they're easy to see. You can actually see them with a pair of binoculars from a dark sky, just as long as the moon is not anywhere near, because that really puts the kibosh on things. And the other galaxy, the 3628, I'm going to have to look up over that one because it's quite obscure. Here we go, NGC 3628, NGC 3628. Not NHC, NGC. This is my ham-fisted typing. Oops, FC, no G. There we are, 3628, not 7. Wow, there we are. Okay. It's a spiral galaxy in the constellation of Leo Trio. Yep, blah, 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 or constellation of Leo, rather. Doesn't really say much about. It's a dust band is obviously deformed in the outer regions of the galaxy, and the reason for this deformation is evidently the gravitational interaction with its two neighbors. So they all had a bit of a smasherini at some stage in the distant past. Well, not really smasherini. They just got close to one another and just got all bent out of shape by the whole encounter. Literally, they did. But they're a fantastic telescope. Fantastic objects to observe through a telescope. We show them quite regularly here at the GDC on our universe exploration night, because with the proper optical configuration, we can actually fit all three galaxies in the same field of view of the eyepiece, which is pretty darn good. So you get three objects for the price of one. And it's a good way to start talking about galaxies and what they are. And galaxies are, as Immanuel Kant described, they're island universes, although his term of universe is a little bit incorrect. They're just vast islands of stars. It contains stars, gas, dust, planets, and somewhere in the core is a supermassive black hole, just like ours. Ours has got a 4.5 million solar mass supermassive black hole at its heart. Messier 87, which is a monstrous galaxy. Its massive black hole weighs in somewhere close to 6 billion solar masses. So that is a serious supermassive black hole. But if you were to have a choice being sucked into, which black hole would you like to be sucked into? The 6 billion solar mass, the 4.5 million solar mass, or a stellar mass black hole? I'd go for the 6 billion one any day because it's much larger. The gravitational forces are a lot less, especially over a large area. So as you fall in, you won't be spaghettified. You won't be turned into a long, thin bit of linguine. Alrighty, Mitch, how are we doing?
So, hi, PK in Balaclava, South Australia. What focal ratio are you guys using to capture these live images?
ZWO. Sorry?
ZWO is not a focal ratio, Rick.
Oh, sorry.
This is a camera. The camera we're using on the
It's been a long day.
The telescope you guys are seeing the images off, that's a ZWO 294MC Pro. Focal ratio, I think for this guy was
I think it's F5.
F5?
Yeah, it's F5, I think.
Yeah. So what we're now doing, guys, we've just slew the telescopes around, and we're going to have a look at the galaxy known as Centaurus.
We got one from Jenna.
Yeah.
Went up to see the eclipse, did the whole trip in 7 days, had to find emergency accommodation, and ended up watching it in Onslow. Oh, bugger. That's it. It's a pity because there was still heaps of accommodation around in Exmouth. We did the trip in, 3?
Yeah.
Yeah, we literally drove up on the 18th. 19th, we went up on the 18th, and we stayed at one of our staff members. Her parents had a friend who owns a property there, and PJ and Trish, if you're watching, thanks again, and also to Wal and oh God, what was her name? I've got a name in my head, but it won't come out. But so they owned the property, and they graciously hosted us onto their property. It was amazing. We just rolled out our swags and had a great time. And then from there, we migrated down to the Kalis site, and we set up camp at the little scientific area where we were. And we were joined by two amazingly kind people from the Shanghai Planetarium. And they came to the observatory a week before, and we met up with them at the site, and they hung out with us, and they got some amazing images, and they had an absolute blast. So it was good to catch up with them. But we did the eclipse on the 20th, and then we just made a beeline out of there, and we ended up staying the night at the Overland Roadhouse, just parked in the back, camped out, and then we drove home. So that was a very blindingly fast trip, but we got what we wanted, we did what we needed to do, and there you go. Alrighty, what we're looking at.
Beauty. So we've now slewed over to a galaxy known as Centaurus A. So this one's a pretty easy one to find. Here we have the Southern Cross, as marked just here. So to get to this galaxy, it's a bit of a hop, skip, and a jump. We're going to start down here at Rigel Centaurus, for you Northern Hemispherians, or Alpha Centauri, for everyone here in the Southern Hemisphere. We're going to jump up to Hader, or Beta Centauri, over to Epsilon Centauri, swing past Omega Centauri. It's a large globular cluster containing approximately 10 million stars. We'll have a look at that guy a little bit later this evening. And then just in here is Centaurus A, also known as the other Hamburger Galaxy, or the Hamburger Galaxy, depending who you are. So what I'm going to do now, folks, is quickly flick this guy back on over here. Screen that one. And we'll clean things up a bit.
Oh, hello. PK Imaging. Hello from PK in Balaclava.
We've already answered that question.
Have we? What? Why am I so delayed? Oh, dude. Anyway, I need to refresh this more often.
Alrighty.
Leave me alone. I'm going to go cry. Oh, hang on a sec. Help send a man to the moon in NASA and Carnarvon 96.
That was Wendy. You remember Wendy came in the other week?
Yes, Wendy. And she referred to our colleague Moston as Mozzie. He hasn't lived that down. It's so good. Moston, if you're watching, you're probably going to kill me, but that's all right. Yeah. Okay. Have you got really? I'm just looking at. Oh right. Okay. There you are. Okay. That's okay. I'm just catching up. Anyway, don't mind me. Yeah, look at that. Oh, there. I forgot. So this galaxy here, Centaurus A, it's bit of a misnomer because Centaurus A is actually the strong radio source in the center of the galaxy that's called Centaurus A. The galaxy itself is NGC 5128. Not a very exciting name, but then you can call it the Hamburger Galaxy, or you can call it all sorts of other things, wherever your imagination leads you, even in the gutter. But certainly, yes, its correct term for the galaxy is NGC 5128, but Centaurus A is the radio source that comes from inside it, towards the supermassive black hole. Mitch, show them the big blast, the plumes that are smashing out of the center of it. It's pretty darned amazing. I'm gonna have to. Here we go. Just keep on. Here we go. Something weird's happening with my. What's that do?
Oh,
What happens if I push that button? No,
don't
that's
push
not
buttons. We know what happens when you push buttons.
Shut up. Oh, now I've lost all the comments.
This is why we don't push buttons.
What?
Alrighty, guys. So this image here is a composite. So if we were to have a look at this galaxy in optical, this is what we would see. As you can see, just like the image we were showing, you've got that nice dust lane that runs through the center of the galaxy. If we have a look at this region in just the radio portion of the EM spectrum, we get to see these large jets, or these plumes, erupting from this central source in the middle. And if we overlay that radio image with the optical image, we get something that looks a little bit like this. So the benefits of radio astronomy, or what we call multi-messenger astronomy, being able to look at the same area or event in multiple different bands or wavelengths of the electromagnetic spectrum, it gives us a bit of an understanding of things that are happening that we might not see with the very limited sliver of the EM spectrum that we can see. We call the visual spectrum. So big thing to note is when we look at things with a radio telescope, we're not, in a sense, listening to space as much as we're looking in a different wavelength of light that we can't normally see. Even the mantis shrimp can't see in radio.
You know, it doesn't deserve to see in radio. It's already got enough color receptors, and I feel really ripped off by not having 12.
The thing is, the bit depth of those color receptors isn't very good. So yes, it can see into all of these wavelengths that we can see, but it's got like 4 or 5 levels of brightness, and that's it.
Oh, okay.
It's
then.
like an 8-bit image. It's terrible.
Oh, okay. Yep. Okay, that's not too bad, I suppose. I feel a bit better now. Yeah, bloody mantis shrimps. Anyway. Alrighty. So, where should we go to next?
Next, do you want to head to Messier 104, the old Sombrero Galaxy?
Or
do you want to move to something different? We've done a couple.
Oh, Omega Centauri.
Next door.
It's right there. It is literally there. Yes, Omega Centauri. Or as my friend calls it, oh my gosh Centauri, because when you look at it, it's, oh my gosh, it's very bright. Speaking of bright, we are on the cusp of sending away the mirror for our large telescope, our large public telescope, the 64.5 centimeter Brodie Hall telescope mirror, to be re-illuminized, meaning a shiny new coating of reflective stuff putting on it. And looking forward to when that does eventually come back. Because the images through that, as in optical, visual, I should say, are going to be incredible. Normally, when you look through a telescope at, say, bright nebulae like NGC 3372, which, by the way, we'll show you a little bit later on, normally you see it as the sort of the blue-green familiar nebulae color. But this one here, because there's such a large surface area, we'll actually be able to see hues of pink. So you'll actually be able to start to see the red color in the nebulosity, which is pretty amazing. And you can only get that with large aperture telescopes. I mean, seriously, large aperture telescopes. Here we go. NGC 5139, the famous Omega Centauri. Now, Omega Centauri is a bit of a weird thing. It's been described as the largest globular cluster in the night sky, although some people have suggested that it may not be a true globular cluster. Rather, it's doing a very good impersonation of one. And that, the alternative, or what it could be, is a remnant of a dwarf galaxy that was literally chewed up and spat out by the Milky Way. Hang on a sec, let me just do this. 5139er. Click. And yes, so 17,000 light years away. It's very, very close to Centaurus A. But to find it, like Mitch said, you progress from Alpha Centauri to Beta Centauri, up and across to Epsilon Centauri, and then continue a straight line between Beta and Epsilon, about the same distance, and you come to a very small fuzzy patch in the sky, and that is Omega Centauri. So outside on a clear, dark night, especially from nice, beautiful dark skies here, you can see it with your naked eye. There was a time in my dim, dark past that I could actually see Centaurus A naked eye, and I did that a couple of times from an observatory way out in the wheat belt, and it was there. But now I'm getting old and I can't see as well, and I can't see it anymore, which is a real shame. But that's what telescopes are invented for, and cameras, and YouTube as well, apparently. So, what can we tell you about this? So, description. It's the largest and most luminous globular cluster orbiting the Milky Way. It is so massive that it is thought to be the nucleus of a dwarf galaxy that merged with the Milky Way a long time ago. So yes, as we can see there, we've got these red-coloured stars, but there's also an inordinate amount of blue stars in there, and they're called blue stragglers. And no one really knows why they're blue. Normally, blue stars tend to evolve into large red stars and then promptly go kaboom. And when I say promptly, I'm talking in a couple of million years. They go supernova. But apparently, Omega Centauri has been known since antiquity. The Greek astronomer Ptolemy listed it in the star catalogue that he compiled in the mid-2nd century AD. Also, Johannes Bayer assigned Greek letters to the brighter stars. He also mistook this cluster for a star. It's pretty difficult because it's kind of fuzzy.
It's a pretty fuzzy star.
Maybe he just thought it was a bit of cloud got in the way and went, yeah, that'll do.
I mean, granted, it is bright. You can see this thing on a
Yes.
full moon, but it's too fuzzy to be a star.
Yes, Edmund Halley, as in Comet Halley fame. So Edmund Halley was the first to document Omega Centauri's non-stellar nature, listing it in 1677 as a, quote, luminous spot or patch in Centaurus. And also even French astronomer Nicolas Louis de Lacaille, he included in his catalogue, and same with John Herschel and a whole bunch of others. So depending which text you look at or information, it can vary from 15,000 to 17,000 light years away. Measuring distances in the cosmos is fraught with errors. So it's one of the nearest globular clusters of the solar system, and it has a diameter of approximately 175 light years across, and it is populated by an estimated 10 million suns, 10 million stars. So that is a serious ball of stars. Do we have any more comments here? No, good. Do we?
William Buck, how much of what you're viewing would be viewable on a 200 to 320 mil focal length range?
You'd see it really well. Oh man, you'd see it amazingly
Something like
well.
this, easily. Some of the galaxies from earlier, if you've got really fast optics.
200 mil, yeah, you'd be able to see it. An 8-inch, yeah. It's you'd certainly be able to see it if you've got dark skies and the moon buggered off.
No. This is 200 mil focal length, not 200 mil aperture.
Oh, okay. Sorry, forgive me.
That's yeah. Tip for GDC fans: putting your Chrome and YouTube scheme in dark is much better. Tip for Rick and Mitch: sharp cap night mode is better. I agree, Ben. My Chrome, basically all of my apps that I use do sit in dark mode. I don't like Chrome. I'm a Firefox man at heart, but and I will share my full sharp cap just to show. I find the yellow or orange color of sharp cap night mode gives me the ick. Not a big fan. Not a big fan.
There we go. Alrighty. What should we go to next? Should we go to?
Alrighty. Can we get to M4 yet? Ooh, not quite.
No, not quite. It's the roof is still in the way.
Messier 46. Let's see if Messier 46.
Oh, you know what we could go for? 6188.
6188.
Yeah. 6188. That's gonna be cool.
Ooh, Dragon's Ara.
Yeah.
I can't see Antares from the roofline, so we can try.
Oh, hang on a minute. No, we can get it. Because if it's just off the tail, it's just off the butt of Scorpius. Yeah, it's up there, right there. So we'll be able to get it.
All right. I'll take your word.
Move the telescope. Slew the telescope to the designated coordinates.
Alrighty, guys. So we're going to come just off the bum end of Scorpius here, so we can see this big bright star. That's Antares. We're going to come down along to his bum. There's a small nebula in here. That's
The Prawn Nebula. Actually, I've been promised. Sorry, I'm just going to interject. There's a whole bunch of seafood up in the night sky, and we're going to endeavour to actually have a seafood night. So there's the Jellyfish Nebula set, but we've got the Prawn Nebula. What else we got? I'm not sure there's some other.
Crab Nebula.
Crab Nebula. Oh, that's
Lobster
summer.
Nebula.
Lobster. Yeah, the lobster. Scampi. No.
There's the Patrick Starfish Cluster.
Yeah, the starfish cluster. Yeah, okay. Yeah. So we could do a starfish. We could do a seafood night. Anyway, we're talking about 6188.
Beauty.
Eesh.
So the dragons of Ara.
Yes.
So the telescope is on its way over there now. It's a bit hard to talk about this object and not mention the dragon's egg
Oh yes.
just down here. That's a nasty little wolf rayet star.
Mm-hmm.
So we'll quickly just flick back over and have a squiz at Sharpcap. Get some things quickly reset. Oh. We do this here. Okay.
Is that 6193?
Huh?
Hang on a sec. 6193. Oh, that's the open cluster. Okay, no worries. There's the dragon's egg there.
Wait for these first images to start.
Yep, let's
Jump over.
bring them in.
Alrighty.
Cold.
Just a bit chilly. I think the
Yeah.
mirror was saying it was meant to get to about 3 degrees out in Yield this evening.
Bloody hell.
So let's squiz what we're sitting at now.
Oh, here we go.
Ooh, this is going to be a tricky one. This is going to be a bit of a tricky one.
What's that?
What a really low signal.
Oh, right. Okay. Yeah.
think
Oh,
that-
there it is. It's
You can
just showing up.
start to
It's
see it.
just.
I think that is in part due to the roof blocking part of it.
Is it? Oh, yeah. I'll tell you what, we can come back to it. Let's just
come
go up
back.
to.
So, should we hit up some of the fan favorites?
Yes.
NGC 3372.
Yes. That's my favorite. I like that one.
You can't come to the southern hemisphere and not see it.
Yeah. I mean, it's naked eye. It's a naked eye target. You can't miss it.
Biggest H2 region in the Milky Way Galaxy.
That is correct. God, have we been going for 54 minutes?
Feels like longer than that.
What? Wow. It feels like we only just started.
Alrighty, so for a bit of context where we're heading over to, folks, just going to quickly jump back over here into Stellarium. We're going to zoom out from the famous dragons of Ara and drag ourselves around here, facing south up towards the Southern Cross. So here is Crux or Crucius, depending on where you sit in the world. We're going to go for a hop, skip, and a jump past the Running Chicken Nebula here, past the Statue of Liberty, all the way over here to NGC 3372, or more romantically known as the Carina Nebula. So this right here is the largest star-forming region in the Milky Way Galaxy. Now, for those of you who've been following a lot of the photos that have been coming out of the James Webb Space Telescope, one of the first images, the first nebulae that it released an image of was entitled The Wall. Now, the Wall itself is actually just here. This is a region known as the Gabriel Minstrel Nebula, and is a slice, this bottom section just in here, that famed Webb image of the Wall comes from.
They're just going back the Gabriella Minstrel. The reason why it's called that is because if we zoom in again, it actually is supposed to look like the profile of the famous poet by the same name. You can see there's the nose. Oh Christ, I can't reach over there. Sorry. There we go. There we are. Yeah, thank you. Let's try with a mouse. Technology. So there's the forehead and the hair. There's the nose. There's the mouth, and not really a chin, but anyway, there you are. If you can't see it, just have another sip of your favourite alcoholic beverage. In fact, have a few. Go on, Mitch. There you
You're
go.
gonna need this because I'm not
me
seeing.
too.
I'm not seeing where you're pointing
Finish
at.
one. Anyway, tell you what, I'll see if I find a picture of Gabrielle and.
We'll hold them up profile side by
Yeah,
side.
that's it. Here we go. No, not fuel watch. Here we go. Here we
Alright.
are.
Let's have a quick squiz.
I think maybe someone was being cruel.
Now, sitting just on the periphery of the Carina Nebula, we have this little group of stars just here, which we'll be having a look at probably just after this guy, known as NGC 3293, also more scientifically known as the best cluster. This here is a nice, tight little open cluster of stars. Very, very similar in composition to the jewel box cluster, but empirically better than the jewel box cluster in every possible way. If there are any other people from the Discovery Center who try to tell you otherwise, that is a lie.
Not sure if you're able to see this. Yeah, nah. No, I can't see it. Anyway, Gabriella Mistral. So,
I'm going to ration you the one beer before these streams.
no, that's the name of it. That's
I know,
where they got it from.
I was expecting something particularly uncanny, and that's the furthest thing
I
got.
didn't name it. Don't look at me, dude. Jeez.
All right, so let's have a
I
look
would have
at.
called it the Alfred Hitchcock Nebula. It looks more like him.
Let's get this stack reset, and we'll get some images rolling in hot off the center here. So we'll go over to our nice tiny little image.
So, did I just hear you dissing the jewel box cluster?
Oh yeah,
Oh, okay, cool.
yeah,
Sorry, Beck.
that's part of my job. Beautiful. So we're just going to wait for the first lot of images to come in.
Yep, cool.
Ta-da!
Hey.
Okay, let me make that
Yeah, weave your magic on it,
a
Mitch.
little bit more pretty. Why is that so noisy?
Don't know.
I don't know either.
Yeah.
Oh, it's the first frame off the stack. Let's get some more data in there. Beautiful. So again, we have the
Ben reckons Ptolemy's cluster is better.
Ptolemy's cluster.
Yeah.
Oh.
You know, I really like the gem. Photographically, the gem is much, much better because it's got that nebula. It's still associated with the Eta Carinae complex, and it's just there's that nebulae that's right adjacent to it, and it's just stunning. We'll show it next, but let's ogle at this one for a little while. That's looking absolutely smashing.
Oh, still gonna get me more data, and there's only 2 images in that.
Still, but look at the oxygen, the O3 regions in towards the
Just in here.
Yeah.
So this little protruding structure just in here is known as the Keyhole Nebula. It gets its name based on its shape. If you rotate that image about 90 degrees anti-clockwise, that'll look like an old school keyhole. And sitting just next to that region is a star by the name of Eta Carinae. It is this big honking star just here. Now, Eta Carinae looks a little bit different when you employ the assistance of the Hubble Space Telescope. And I'll just quickly pull up an image for you guys to show exactly what I'm talking about. Here at the center, we've taken to referring to this structure, was more commonly known as the Homunculus Nebula. In-house, we call it the Space Peanut, and it'll become very evident in a moment as to why that is. Where is she? There she is. Homunculus. Space Peanut. Beauty. So I shall flip this over for you guys now.
There we go.
Beauty. So this here is the Homunculus Nebula. Now, people often get a little bit confused with these 2 lobes here, thinking that those are the stars Eta Carinae A and Eta Carinae B.
No,
that's
not
the case. Not the case.
No.
These 2 lobes here are the outer shells or the outer envelopes of these stars. If you think like the outer layers of an onion almost blowing off. I love to put this into human terms. Astronomy is a very complicated thing. And when you break things down into human terms, things are a bit easier to understand. We deal with humans every single day. So imagine for a moment if you had a big red button in front of you and you press this button and all of your skin ejected. That's effectively what's happening to these stars. Now, if I was to walk into the same room that you've just done that in and meet you, I would make the very common assertion that you were probably going to die soon. The same thing is applying to these stars. We see these outer envelopes ejecting off they are in their death throes and they are destined to go supernova sometime relatively soon in astronomy terms. So
I wonder if you could use the analogy that,
10,000
like,
years.
next time you're about to have a sneeze, you hold your nose and close your mouth, and then as you sneeze, your eyeballs are ejected out through your ears. That might work.
maybe. I don't know. I feel like it's skin though, because it's the outer
Yeah,
the outer
true.
layer, the outer envelope.
Yeah.
Alrighty. But no,
But
the stars themselves are hiding just here in the center.
so that was a great eruption, 1843, that caused it. So it flared up to be the second brightest star in the night sky, about the same magnitude as Alpha Centauri up there, and yes, it stayed that way for a couple of weeks and then faded off into obscurity beyond naked eye limits. And since then, it's gotten brighter and brighter and brighter. It is now within naked eye limits. And of course, this is a precursor for this star to go foom. That is, of course, a technical term we use in astronomy. When a star goes foom, it usually denotes it's going to be a supernova. Not really. But yeah, when it does, it's going to put on a heck of a show. It's estimated its luminosity will increase millions of times its luminosity now, and we'll actually be able to see it during the day for about maybe 2 months. And certainly at nighttime, it'll be really, really bright. It would probably, hopefully, be bright enough to cast shadows on the ground. But watch this space, as they say. So what do we got next, Mitch? Oh, we're shuffling over to...
So I've just had
Hello.
a recommendation from PK. If you head back to Scorpius, I recommend a brief visit to NGC 6441, the Silver Nugget Globular Cluster. It's roughly 40,000 light years away, next to the star G Scorpius, called Fourier, which is about 4,000 light years away.
Called what? Fourier.
Fourier.
Isn't that what Uncle Roger says? No, he says Fourier. That's right. Mitch is going to hit me.
You make me put my foot down off my stool. Disappointed in you. Nephew Richard.
Yeah.
Disappointed. Based on the field of view, would it be a bit of a tight one?
Whereabouts is it?
It's just in the
Oh.
back end of Scorpius. So from where we're sitting right now, it's still not up past the roof. So we will endeavour to make a pit stop back towards him, probably a little bit later on towards the end of the stream. But I think what we'll do now is go a bit of a hop, skip, and a jump over to NGC 3293.
Oh, yes. NGC 3293. That's a good one. That, of course, is the that one, the gem cluster.
I will say, I do oftentimes say that no, this gem is the best, but I do have a bit of a partial loving to the Sprinter cluster. So a nice big open one, nice exclusive southern hemisphere target, also known as the Southern Beehive. It's a nice little cluster. A bit too big for the field of view of this telescope, unfortunately. I'll have to bring my my little refractor out one day.
Yeah, indeed.
Nice and wide, because that thing will fit M8 and M20.
Oh,
side by
yeah,
side.
yeah,
It's
yeah.
pretty big.
Yep, absolutely.
Pretty big.
Oh, boy.
Alrighty, so.
Wow, so this is about 8,400 light years away when we start getting some photons.
Yeah, clear the stack up.
I was going to mention, next time we do a live Sky Astronomy, we might change the optical configuration. So instead of having buzz on there, we might just use a wide field camera, like a big wide field lens, so we can actually start getting some of the dark dust lanes of the Milky Way.
Do some of those big Barnard's catalogue objects.
Yeah. I mean, middle of winter, when we'll really be freezing our butts off, we could zoom in towards the core and look at some of those dark dust lanes like the Snake Nebula and the Pipe Nebula and a whole bunch of others.
Heaps of stuff in LDN, Lynn's Dark Catalogue. Nebulas.
Yep.
Oh, so we've got in the center here, we have the gem cluster, and then we can see just off to the edge there, we have the beginnings of what's coming through as the Menstrual Nebula.
Yep.
So just give this a bit of a tickle. If we can tease a little bit more out of it.
Yep. There should be some whole bunch of nebulosity around.
We can start to see a bit of faint there. The flats I took earlier are not agreeing with me for some reason.
No. I was going to say, we're not live stacking, are we?
No, we are live stacking.
Sorry, we are?
Yeah.
Oh, okay, no worries. Well, we'll just let that stack away. It consists of more than 50 stars, and the brightest of which is a red giant. Where is it? There it is. That's the red giant. So it's of magnitude 6.5. Anyway, there's some nebulous material, gum 30, which is visible, floating between the stars, which have probably formed from it. So that's probably still a remnant of its stellar nursery, still lingering around. So it is particularly high abundance of hot young blue stars. The hottest is a spectral B class star, which is B for bloody hot. No, not really. O is the hottest, of course. That's like, oh gosh, it's really hot. A study of NGC 3293 implies that the younger stars are only about 6 million years old. Oh, but whippersnappers they are. Oh, look at that. Hang on a minute. That's not the one. Okay, that's the one that you took.
This is not our image.
Jeez.
Here's one I prepared earlier with
Wow.
the power of television imaging. TV astronomy. But
Yep.
yeah, you can see that nebulosity sitting down in the background there. We've got those lovely big
Yep.
K-type supergiants and all those lovely young hot B-type bloody hot blue supergiants.
Yep. So
Back to the good stuff.
let's see what we've got, because time marcheth on.
What have we got next on our list? The jewel box.
Jewel box. Do we really want to go for the jewel box? There's a bit of a step backwards.
Yeah.
Yeah, no, let's ditch it. Let's oh, here we go.
I just need to take.
Ben says if you head back, if you 135 mil for a row of Fuki and the Blue Horse, highly recommended. Yep. Unfortunately, we've got a large roof that's blocking our view, but certainly next time we will absolutely do that. Now, let's go to the moon. The moon's over there, looking all
The moon?
pale and sickly.
All
Yeah,
right.
time to moon.
So I'm just gonna.
Here we go. Do you want me to point the telescope, the torch?
Yeah, no, should be right.
There we are.
There you go. So time to go to moon.
Or B-Rock, as we call it here in the observatory.
We do?
The B-Rock.
Used to me.
You hear us say it all the time.
Anyway.
Bastard rock.
Oh, yes. Cursed space egg. Oh, that's good. Nothing's going to smash into anything.
I hate. For anyone thinking of getting an EQ6AZ, the elevation bolt.
Yep.
Hate it.
That's a
Clutches are good. Clutches are big and chunky, but elevation bolt.
bad design. Here we go. La Luna.
Alrighty. I'm gonna have to do some quick magic here. Kill some lights.
Yep, here we go.
We're gonna have red moon again.
Here we are.
Because someone forgot that there was a filter on the front of the telescope.
Yep. Guilty as charged.
So we're gonna jump out of our live stack now. We don't need any of that. We're gonna come straight back into 30 seconds. Absolutely not. We don't need anywhere near that.
Wow.
Go for about
There it is.
200 milliseconds, if that. Crank that gain right down.
Oh, might need to.
I'm gonna have to jog him in.
Yep.
Okay, let me fix up some gain here.
Yep. Yeah.
All right,
Drop
I'll go
that down.
back on
All right, I'll tell you if you're going in the wrong direction. Nah. Pick another button. Nah. Yeah, that's good. Keep going. Oh, look, the moon's rising. Keep going. Yep, keep going. Keep going. Doing well. Nearly there. And stop. Beautiful. Just need to adjust the gain and stuff on that.
It's all good.
So yeah. Oh, zippity doo dah! Look at that.
So we're gonna
Zoom in on it.
quickly have a look at what we're seeing here first.
Yep.
So Luna. Now I can get just a touch closer to her and move her over there for you guys.
Cool.
So I might actually swap to Buzz for this one because Buzz has got a bit of a higher frame rate.
Ah, so that was done through Copernicus,
So
right?
Copernicus, yeah.
Oh, okay.
Buzz has got a much higher frame rate.
Mm-hmm.
And a nice little planetary camera. Also means the sensor is a lot smaller.
Yep. Turn that off. Wow.
It's just a little bit of alignment.
Ah, do you want me to? I'll tell you what. Okay.
I'll jog him in. So if we swap over here to Buzz.
Yep.
Quickly jog Buzz in.
Yep. No worries. Tell you if you're going the wrong direction. No, other way. Yeah, keep going. A bit more. All right. A bit more. Stop. Perfect. Nice. Now we can see the bunny. So the Sea of Serenity, the Sea of Tranquility, the Sea of Fertility, and the Sea of Nectar. I remembered it this time. Wow. Normally I forget it. But here we are. Let me, I'll see if I may borrow the moose. Thank you. Yeah, I'm going to point. So, can we invert this image, as in like flip it around?
I might be able to.
Yeah, okay. Doesn't matter if you can't.
No, it's the moon. All the lunar maps are written for Newtonians anyway. Get your
Yeah.
screen back.
All right. So that is the Sea of Serenity. There is the Sea of Tranquility. There is the Sea of Fertility, and that is the. Oh God, I forgot it now. What was that one called? I just said it a second ago.
Huh?
The Sea of not the humidity. God damn it.
Humidity. The Sea of Humidity.
Shut up.
Tranquility, fertility, nectar.
Nectar
and
no, fertility and nectar. So that's the Sea of Nectar. Yeah. So tranquility, serenity. No,
Yeah.
serenity, tranquility, fertility, nectar.
Yeah, tranquility, because Apollo
gosh.
11 is there.
Yeah, Apollo 11 is. Hang on a sec. Let's zoom it in. Yeah. Go boink. That's a bit blurry. I think it was on this side here. I can't verify that. But yes, and before anyone asks, can you see the moon landing site? No, we can't.
Otherwise, we'd zoom in and verify that for you.
That's right. But there's a number of amazing craters. So these are the lunar mare. And the lunar mare, of course, you notice are darker than the surrounding lunar surface. The other lunar surface, of course, is heavily cratered, and those areas aren't. And that is because those areas are sites of ancient impacts that occurred about 3.8 billion years ago, something called the heavy bombardment phase of the formation of our solar system. And we had these giant mountain-sized rocks, mountain-sized asteroids careening around the inner part of the solar system, bashing into things like Mercury, Venus, Earth, Mars, and of course the moon. And when they hit the moon's surface, they hit with such ferocity that they crack through the thin lunar crust and cause local volcanism. So molten rock welled up through that impact site and formed these vast lava lakes that eventually, took a long time to cool down, a few hundred thousand, a million or so years to cool down. And eventually when it did, it formed these dark impact sites called the lunar mare. Now, clerics way back when thought that those were bodies of water, and in fact, some clerics went as far as to say that the moon's surface was smooth and polished, just like everything else up in the heavens. It was perfect. But then along came Italian troublemaker and part-time astronomer Galileo Galilei with his telescope and looked up and said, "Nah, it's lumpy." And sure enough, it was, and he got into a whole bunch of trouble, and that was only just the start of his troubles, because then he brought up the sticky topic of Jupiter and why its moons moved around. Anyway, that's a story for another time. But there's another crater just off to the right of the Sea of Tranquility, and that circular one there is called Mare Crisium. And inside there's actually two rather interesting craters. One is called Pierce, and the other one is called Picard, as in not named specifically after Jean-Luc Picard of the Star Trek universe, but certainly there is a crater there. But Where is? Hang on a sec. What was the name of that crater?
That was
Sounded
crater.
like Lignocaine.
No, it wasn't Ligma crater. It was Langrenus.
Ah, yes, of course. That's like 130 something. I nearly said 130 light years across. It's not that big. It's 132 kilometers across and about 2.5 kilometers deep. Now, I was in Kalgoorlie just last week. Last week, yeah, something like that. It's all a blur, of course. It was a tourism conference, and it was in Kalgoorlie, and we went to visit of course, the super pit. And the super pit, I found out some stats about it. It's like about 7 kilometers in length. It's 7 kilometers in length? No, 3 kilometers in length. About 1.7 kilometers across, and it's about 600 meters deep. And with some very poor, rough mental calculations, comparing that to one of the other craters that we can't see at the moment because it's in the nighttime part of the moon, one called Tycho. Tycho is 4.5 kilometers deep. So it's 7.5 times deeper, approximately, than the super pit in Kalgoorlie. So that is one heck of a hole in the ground. And it's also 87 kilometers in diameter. That's, of course, is Tycho. Copernicus is much larger. That's about 92 kilometers across and only 4 kilometers deep. But yes, if I wonder if we can zoom in on the Terminator. And of course, I'm not referring to Arnie. I'm referring to the day between night and day. And it's a little bit fuzzy. That's just because of the optics of the.
I'm just swapping out again. I'm just trying to get a bit of a better frame rate for us.
Oh, okay, no worries.
Because it's going to jump in all over the place.
Yeah, okay. So, one of the best times to observe the moon is during like tonight. And also the first quarter phase and a couple of days after, because you get that shadow play along the actual night and day, as we can see there. It gives a really strong relief.
No, with these sea conditions, it's not.
No, it's pretty darn toxic. There's a
wobbly
thin
more than a
cloud.
plate of Jell-O.
There's a thin cloud at the front. But if everyone wants to go outside now, I know you're all warm and snuggly on the couch, but go outside now. Just go. And if you look out towards the moon, you see two stars above it, and it's giving you a bit of a smiley face at you. Of course, the top star is that forms one of its eyes. Of course, is Regulus, and the other one is I think it's Algebra in the constellation of Leo. So it's the back end of his fat head. So if we have a quick look, I might confirm that name of that star.
Algebra.
Algebra or Algebra? It depends. Hang on a sec.
Right here.
There's an I there. Algebra. Anyway, there you are. So, yes, those two eyes are two stars of Leo. There was the famous smiley face that was, this is impersonating, of course, back in 2008, I think, the 1st of December. And of course, that was Jupiter and Venus providing the eyes, and of course, the crescent moon providing the smiley mouth. So go outside and have a look at the universe smiling at you. Well, it's probably just laughing at you, but no, it's probably just laughing at us. So yeah, go outside and enjoy that. Hey, Galen, long time no see. How are you? Hope you're well. Hope everything's going well for you. Yes, let's just see if we've got any more folks tuning in, because we've really gone over time on this one, Mitch.
Can you see the soundstage where Apollo Creed landed?
Apollo Creed. That's someone's attempt at humour, and it's kind of worked.
Ben's saying the altitude bolt on the EQ6 is there to promote good cable management. All it is doing is promoting me going to Bunnings and buying a grinder.
A hacksaw. Yes.
Don't get me wrong. I love the mount. It's fantastic. I love freedom finding encoders. But if they could just make it a little bit shorter, that would be fantastic. Particularly when you're as boisterous as us and try and load this thing up with as much as physically possible.
Yeah, that's it. Yeah, really putting strain on it. But that's actually well balanced.
It's done the job.
Prefer well.
All right. Should we round it up with one final target?
Yeah, why not? What do we got?
Shall we have a look at?
Sombrero.
Sombrero?
Yeah, Sombrero. It's oh gosh, it's pretty much zenith. It should, yeah, it'll pop on. So the telescopes will be on the east side of the pier, so that should be okay. Nothing's gonna get tangulated
Alrighty.
and crunched.
East side of the pier. I'm taking your word for it.
Yeah, well, I hope so. Whew. Oh, interested to find out what the temperature is. Maybe I shouldn't find out, but yeah, I'm going to. Oh gosh, it's 6.8.
And
It
dropping.
feels like 4.1.
And dropping.
Yes, it is. I think I have toes.
Allegedly.
Allegedly.
Uh-huh.
Yes. Well, I better get in practice because I'm going to New Zealand in October, and I'm going to be heading down to the Mount John Observatory, and of course that's going to be colder than something. I can't say it. I'd like to say it, but anyway, it's going to be freezing. But I'm hoping that the solar activity really spikes when I'm there, so I can see the fabled southern lights. Where are you going? It's going to the west side of the pier. You fascist! Unbelievable. What's wrong with you?
Because I bet it's like a whisker off the meridian.
Oh, it's like 2 minutes off the meridian or something daft like that. Yeah. So I'm hoping that I'll get to see Aurora Australis whilst down in near Lake Tekapo Way, or even just anywhere in the South Island, New Zealand. So it would be good. I've got some rallies over in Christchurch. Go say hello to them. But yeah, if I can catch the Aurora, that would be absolutely smashing. Might even do an impromptu live Sky broadcast from there. We'll see what happens.
Yeah, and I'll be on the tech support line.
Yeah, Mitch.
I told you, it's a whisker off the meridian.
Oh,
Just an absolute whisker away. Give it, what, 5 minutes and the telescope would have
Yep,
decided to go to the other
yep,
side of the pier,
yep.
but alas. So, I'm going to have to quickly... Do you want to wax lyrical on Stellarium for 2 seconds whilst I pull up a nice image for us?
Yeah, sure, no worries. So the Sombrero Galaxy found in Virgo, it's actually lies about 2/3 of the way up between the bright star of Spica, which is the brightest star in the constellation of Virgo, and Corvus the Crow. And it's from memory. I think it's about 21 million light years away. Let's have a look. 28 million light years away as the crow flies through the vacuum of space and promptly explodes because there's no air pressure. Anyway, so the Sombrero Galaxy, of course, is a spiral galaxy in Virgo, and the thing that really, really sets it apart from all the other galaxies is that dusty, dark edge to it. This really shows you that the analogy of two fried eggs slapped together, and of what a galaxy looks like. And of course, this really shows it off. It is pretty darned amazing. Let's see if we've got anything. It was discovered by Pierre Machin. Charles Messier made a note of it in his object, in his catalogue, and 5 others. Blah, blah, blah. First galaxy for which a large redshift was found by Vesto Slifer of the Lowell Observatory in Flagstaff, Arizona. What the heck is that?
That's the meridian.
That's the meridian.
It's the meridian as it's crossing the meridian.
Yeah.
I can guarantee you, I walk up right now and I press enter on the map, it'll flip.
It'll flip, yeah. Gosh, look at that. That's crazy. Is people seeing that?
Yeah, that's live. So yeah, that green line coming across the
there
screen.
we are,
folks,
and
that's
it's
the
like
meridian.
right crossing the meridian. There we go.
That's all right. I've
Cool.
got an image coming through on Copernicus now for us. So I'll quickly
Okay.
tuck this guy up here.
Oh, has a linear diameter of 130,000 light years, which makes it slightly bigger than ours. Has a symmetrical dust ring that encases the central bulge and also contains most of the galaxy's cold hydrogen gas, and is the primary site of star formation within the galaxy. So stars are forming right along its dusty edge. Cool.
There's a couple of surveys in, I think it was infrared, where they they just peer through those dust clouds around the periphery, and there's no hydrogen in the guts. It's just all sitting here in the dust.
Wow.
It's
Okay.
a weird sight. Ben Johnson, Live Sky in New Zealand, 10 tuis deep, will view. Yeah, if you guys start the beer fund now, I think we'll be ready to go by the time he heads off.
Yep.
Pretty smoky here in South Guildford, but I went outside and saw the smiley face. Brr. Yes, it is quite chilly out
Yay!
there. Thank you very much for going out and confirming that for us, Melissa. We are seeing the same thing.
Yep, it is pretty darn cold. Whew. Yep. So there's the Sombrero Galaxy. That's there was another picture. So there's a Hubble picture of the Sombrero, and there's two distant galaxies just quite a way beyond it. Down in the bottom corner. There they are. So behind the little pop-up menu.
Oh, wait. Let me do the thing.
All right.
Let me do the thing.
Yep, do the thing.
No,
No,
that's Andromeda.
No, it wasn't Andromeda. That was 253. So go down. There's a couple of galaxies there, and there's two of them interacting, two face-on spirals down there that are very reminiscent of the Spanish Dancer galaxy, NGC 1566. So look at that. That is stunning. And then there's something else there. That's a weird thing there. Or was that a no? That's a real thing. So there's a whole bunch of galaxies, and look at that faint one down there.
I can only zoom in so much.
Yeah.
And we're getting to the point, is that a cosmic ray or something?
Hey,
Edge on?
until we get optics, like the James Webb Space Telescope or Hubble, well, we have to
But
make
even
do with what
still,
we've got.
the level of resolution in that dust.
Look at that.
And you can see that the bulk, as I was saying earlier, with the bulk of that hydrogen being in that dust, there's some faint red patches in here as well. But the bulk of those clusters seem to be inlaid and inset throughout that dust.
And there's very little in towards the center. I mean, you can see there's a little bit there.
Oh, there's some
But-
faint trailings.
Yep.
Very
But a
faint
lot of it is on the edge.
There was a supermassive black hole in the gut to this one, wasn't there?
I think
Is there a
so.
billion solar masses?
I don't know. I haven't picked
I
it
know
up.
it's chunky. Very
Yes.
chunky. But again, this is
Yep.
this is what happens when you get Hubble. This is what you get when you are terrestrially bound.
Yep. Well, we make do with what we've got. Actually, you know what we should actually do when we get the mirror back from Brody? We should actually image through that. Couldn't hurt.
Seraphim Jade says, slightly off topic, but I just wanted to say I absolutely adore you both. Love chatting with you guys when I'm at the Gravity Center. Love you guys. You're the best. Thank you very much.
Oh, checks in the mail. Thank you.
Thank you very much. We appreciate that.
That's
Honestly, anyone who comes up and takes 5 minutes out of the day to have a yarn with us,
Yep.
yeah, very, very much appreciated. Thank you very much.
That is very nice. Whew. Gosh, a bit cold. But anyway, I think we'll finish it off tonight
We'll wrap it up
because
there.
I need to go and get a hot coffee in me because I am cold, I'm freezing, and my toes have run off into the darkness.
Too easy.
So yes.
Beauty. Any final words, Captain?
Let's see. Final words. Be nice to animals.
Be nice to
yeah,
animals.
be nice
I
to
would
animals.
concur with that.
Yeah,
Be
yeah,
nice to
absolutely. Yes. So look, folks, thank you very much for joining us again on this very chilly, cold, beautiful, clear night here at the Gravity Discovery Centre. We had a lot of fun. We always have a lot of fun doing this kind of stuff, and we're going to do more of it because, well, why not? Because it's just so much fun. So look, enjoy the rest of your weekend. Stay safe, and we'll catch you again on another live Sky Astronomy session. So from Mitch and